Hello everyone, welcome back. I have started this channel last month and I used to do videos in my native language. But most of my friends requested me to publish content in English, so here is my first attempt. This is the first video in OSPF learning series and I will be going through the fundamentals of OSPF. As you see here, this is what I have in mind for OSPF. We would be exploring OSPF at packet level with help of labs in future videos, and there might be some more videos than what I have listed here, and I might combine few of them to keep it short and sweet. Before starting OSPF, let me just refresh the basics of routing protocols. They are classified into two. First one is EGP, which stands for Exterior Gateway Protocols, and the second one is IGP or Interior Gateway Protocols. EGP is used to communicate between different autonomous systems. When you say autonomous systems, they are nothing but a network which is under one administrative control. And BGP is an example for EGP. Whereas IGP is used within an autonomous systems and they are further classified into two based on how they operate. First one is distance vector protocols and the second one is link state protocols. As the name suggests, distance vector protocols operate based on two things. First one is the distance or the metric to reach the destination. And the second one is vector, which denotes the direction of traffic. Distance vector protocols are also called routing by rumor because any given router will only be aware about what its neighbors are sharing with it, which means they don't have the full network view. In this example, R2 shares the distance to destination with R1 and R3 shares its distance to destination with R1. R1 blindly trusts the information from R3 and R2. Also, R1 knows it can exit via R3 or R2 to reach R5. So that covers the direction part of it. In case of link state routing protocols, each router in the network is aware about the entire topology. For example, in this topology, R1 knows about the cost of all these links which is present in the network. So R1 can decide for itself which is the best path to reach the destination. I will cover this in more detail when I explain the working of OSPF because OSPF is a link state routing protocol. As I just mentioned, if all the routers in the network knows about the entire network, then that doesn't sound much scalable because everybody has to process all the information within the network. So if it is a bigger network, then the amount of information each of the routers has to process will be very high, and that's not a scalable solution. OSPF tackles this problem using area concept. We can divide one large network into smaller OSPF areas where all the routers within a given area will be fully aware about what is happening in that area. So all the routers within that area will exchange the entire routing information between each other. And between areas, there will be special routers which would only share summary information between these two areas. Also, each routers participating in OSPF will have a database called Link State Database or LSDB, where it will keep all the information related to OSPF. And all routers within an area must have same information in their LSDB. And as you see here in the LSDB of R1 and R4, it has the information within that area and it has a summary information across the areas. So by having this area concept, the size of the database will be under control and which would help the OSPF to scale in a much larger environment. Another advantage of having OSPF areas is that it improves the convergence time. OSPF uses SPF algorithm to calculate the best path. So if there are many entries in the database, the algorithm will be slower to find the shortest path as it has to go through all the entries in the database. So by breaking larger network into smaller logical areas, the OSPF database size remains smaller and which in turn improves the efficiency of SPF algorithm. So to summarize, all the routers within an area must have the same LSDB and only the best route details from an area will be exchanged to another area. And the area concept increases the scalability of OSPF and improves the convergence time. Every routing protocol will have an inbuilt mechanism for best path selection. We often refer them as metric. In case of OSPF, it uses interface cost as the metric, which means each interface participating in OSPF will have a cost assigned to it, and this will be based on the type of the interface. So if we want to do path manipulation, we can change this cost at an interface level. Here in this example, the cost to reach R5 is lowest via this particular path. So R1's SPF algorithm will choose this path based on the lowest cost, and the traffic will be sent across this path. When OSPF is configured between two routers, they will dynamically form neighborship. This is because all the OSPF enabled routers will be sending hello messages on a multicast address 224.0.0.5, and all these routers will also be listening on the same address. So routers in the same L2 domain will form this neighborship dynamically. I will show the contents of OSPF messages in a future video where I will be covering each messages in detail. There are a couple of important timers in OSPF. The first one is hello interval. This determines how frequently these hello messages are sent. The default value is 10 seconds, which means every 10 seconds the router will be sending out a hello. If a router doesn't get hello for a period exceeding the dead interval, then the router assumes that the neighbor is no longer active, and it will tear down the neighborship. The default dead interval is 40 seconds. To form neighborship, OSPF check few things which are present in hello messages. The first one is both of the routers must be part of the same area, which means R1 and R2 should be in the same area. The second point is both routers must be part of the same subnet, which means R1's interface towards R2 and R2's interface towards R1 should be part of the same subnet and mask. The third point is both these routers should have same kind of authentication, either none, or if there is an authentication present, that should be same. The fourth one is step flag, and it should match. I will be covering this in detail in area types video. And the fifth one is timers, which means hello and dead timer should match. I think this pretty much covers the basics of OSPF. As I mentioned in the intro, this is my first video in English, so please do share feedback, and thanks for watching.